good to have the opportunity to show some math. So we're going to work on the law of sines right now this week, and possibly law of cosines as well. So I'll go over a couple of things on it. This is the law of sines. So if you're looking at a triangle ABC, then you're going to basically some key points. Side or your angles A, B, C are going to be your uppercase. Your side A, B, C are the lowercase, and they will always be opposite. Right? So lowercase a is the side opposite of angle A. Lowercase b is the side opposite of angle B, and lowercase c is the side opposite of angle C. So when you're doing law of sines, you're just going to plug numbers in and solve for a missing variable. With the law of sines, A over the sine of A is equal to B over the sine of B, and which is equal to C over the sine of C, meaning that they are just proportional. Your sides and your angles are going to hold true to proportions. So what we'll do is we'll go ahead and jump over to see a couple examples really quick. So let's look at these. So right here, we're trying to find side AC. So we're going to go ahead and call side AC X. And we're going to try to solve for it by using the law of sines. We are only given one side, side AB, and we know that it's 24. Okay, so to use law of sines, I'm going to have to know the opposite angle from the side that I'm given. So I have to solve for this using my angle sum theorem. So in a triangle, I know that I have 180 degrees, 118 and 22 is equal to 140. So 180 minus 140 is going to equal 40. So I know that angle C is going to be 40 degrees. And now we're just going to use law of sines to set up this problem. So because I'm given angle C and side C, I'm going to say 24 over sine of angle C, or 40 degrees, is equal to my side length that I'm trying to solve for, which is x, over sine of the angle that's opposite of x, which is 22. Okay, from here, all I'm going to do is multiply. Right, I've got to isolate x. In order to do that, I multiply by my denominator, multiply by sine of 22, it cancels here, and so now I have sine of 22 times 24 over sine of 40, and I can't remember exactly what it works out to be, but I think it's 13. Let me check real quick. Oh, it's not. It's dead, apparently. There we go, turned on now. So sine of 22 times 24 divided by the sine of 40. Oops, I am in radians. Change that to degrees and do it again. And it is 13.98, which would round up to 14. So x would be equal to 14. I'll show another example here in just a second. Hopefully this makes sense. Let me go back really quick. Let's go ahead and get out of this. Here, so even though you have sine of A over sine of A is equal to B over sine of B is equal to C over sine of C, you're not having to use all three of them each time. You're just going to use, so for example, if I knew here that A was the 24 that we just solved for, and this was 40, and this was the 22, right? I'm only going to use A and B in my calculations. I don't have to worry about anything here, okay? we'll run through one more example over here, and hopefully that will be enough information to help you out. So, really quick on this one, right, I have angle, I'm given angle B, I'm given angle C, and I'm given side B, right? This is lowercase b because it is opposite of angle B. So I'm going to use 7, or side B, right, over sine of B, which is 44 degrees, is equal to, I don't know this side, and I'm trying to find it, right, find AB, so that is my x, over, and here's my 53, so sine of 53, because it is the side, or the angle given opposite of x. And then from here again, just isolate your variable, sine of 53, that cancels, you have sine of 53 times 7 over sine of 44, and that is going to be 8.0